How are you doing? It is Sunday, and we are live, I believe, on Facebook and YouTube. I don't know. It's been a while since I've done these live streams, and I'm struggling a little bit about figuring it all out. But I hope you're doing well. We'll see how it goes. If things are not working out, then we'll just chop out the record, replace whatever goes live with the recording, and hopefully we'll be all good. Happy Sunday, everyone. This is the Ask Live. This is the third Sunday audition doing here. And pretty much what we're doing is just going through some of Lars's emails. I'm having a hard time going through all of my emails, and so I'm just going to go through some emails here. If you like it, thumbs up. If you don't, just thumbs down. That's all good. Leave the comments. Love the comments. And yeah, just trying to ask some Fusion 360 questions. It's Sunday afternoon. Things are good. Hope things are good with you. I got some coffee. I got some water. So let's try this. I have another thing going on today. What is the Ulchi maker right there is running. I'm not sure if the noise from that one will interfere with the recording, but I thought, hey, why don't we try it? So somebody's gonna ask me what is it cutting? It is actually cutting this heart here. Somebody sent me a link to this. So this was done by Ole Acorn, and I honestly don't know what program Ole used for this heart, but it looked pretty amazing. And as some of you guys know, I'm fairly new to 3D printing, and I thought, why not? Why don't we just run that and see how it goes out? It needs a bunch of support material, and the Ultimaker has some pretty cool support material that actually dissolves in water. So I thought, I'll try that out. So that's just running. It's going to take a day or so to do that. So that is not super exciting. But as far as I can see, we already got some people online, at least on the Facebook. I'm not going to take any comments or anything like that on this one. Maybe we do that in a future version. This one, I'm just going to get through these emails here. So let's get to it. First email is from Frank Vergara, who asked, hey Lars, what's up? Hey Frank, what's up with you, man? Hope you're doing good. Enjoying all the content. That's awesome. Really appreciate that. I was wondering if you could do a simple CAD-CAM part and then possibly set it up and insert the part into a CNC machine. That would be a cool live video. It would be. I'm not quite sure I'm set up for that right now. I've had a lot of cool plans. I had a plan, so some of you guys know that I had the Stepcraft down in the workshop. I was actually also looking into getting a CNC machine in there at some point. That hasn't quite happened. But what I will say for right now, so Frank, that's a good idea. I'm not quite sure I'm there yet. But so again, this is what's running on the 3D printer if anybody's asking. But if you go out to YouTube, go to the favorite YouTube channel, whatever's your favorite. Let's go to my channel here. So this is if you go to my channel. Oh yeah, I am live right now. Woo! Hopefully that's working. I hope that this is not the title. That would confuse some people. We'll change that later. But if you go to the playlist right now, Frank, you will see there's a lot of different playlists in here, but there is one that is specifically CAM. So let's just see here. I should be more organized. There's a fly in my office too. So there's a CAM quick tip. That's all the live streams. Make anything. They get moved around as I'm making stuff. Let's see. This is probably this one here. If we click on this one, and down here, how to get started with CAM within Fusion 360. You can also just, of course, type this into your search in YouTube. But if you search how to get started with CAM within Fusion 360, this is a video series I did that I think you would like, where I'm explaining how to machine this entire part here, and it has a lot of good functions in it. I don't have a video right now where I then will take this part and go and machine it. It was a hope for me one day to do that. But so Frank, for that, go and check this video out. I think that will be a good starting place. Doing all the other stuff with getting it loaded into the control, that was a plan. I'm not sure if it's going to happen right now. All right, we'll move on. Thank you, Frank, for the email, by the way. Next one is from Casper Johansson. Hey, Lars. Hey, Casper. I'm trying to make a cam for a model in Fusion 360. I want to CNC it, so another cam one. We will do some different ones. It's not all cam. Promise. He's using 3D ramp to do this part. And you know what? I don't think... I should probably have had an image of this one, but I don't have an image of this one. Mistake on my part. I am sorry I didn't get that image in. Sorry about that, Casper. But I will show you another option. So what Casper is trying to do, let's get into Fusion. Let's get Fusion going. And let's just quickly model something up here. So I am going to model something up that is similar to what Casper is trying to machine. At least I think. So I'm just going to model. And I'm not constraining anything. So anybody want to yell at me for that, that's okay. You can do that. No hard feelings. Everything should be restrained, but I'm not going to do that in this one here. I'll make a couple of tangent arcs here. Something like that. A line over. Get alpha line. Alpha line. Put that there. And let's just make sure we get one. Make that 22. 22. So at least it somewhat looks like something. So what Casper is trying to do, if we extrude this thing up, is he's trying to machine a part that looks somewhat like that. See how it's kind of like have a curve on it there, right? Have a curve up around it like that. And what he's using, that's probably a little tall. Make it a little lower. What he's using is the 3D ramp tool path, but it's actually a pretty cool tool path. But the problem he has is when he's cutting this out of a sheet of something, is that he actually wants some tabs in there. And if we go into the manufacture tool button here, and we had a sheet like this, and we're going to machine this out of this, we'll leave that like that. He's using the ramp tool path, but it's actually, like I said, a pretty good tool path. If we select that, and let's select a cutter, let's go in and do, since we're doing metric, it's like the 5mm cutter here, something like that. And whenever I do 3D toolpath, so the ramp toolpath is a part of a 3D toolpath, I actually just normally just hit OK and see what it gives us. Okay, so it gives us a toolpath that actually looks very, very nice for this part here. We'll run out of flute length, but one of the good things here is if we click on this one here and we go to the ramp, it actually gives a little description on there. And you can see that it's create a finishing operation that intends for steep areas, so that means straight area of walls down, close to the contour strategy toolpath, the 2D contour strategy toolpath. So what it does, if I simulate it, is, and you're going to get collisions, but it's ramping down. So it's actually kind of like just going further and further down, like a constant Z movement. Actually, if we click on the info tab over here, you'll see the info tab over here. You would actually see that it shows you that it's just constantly, the Z is just constantly going down in a ramping style. So if you're familiar with CAM, that is kind of cool. It's just kind of like ramping down all axes at the same time here for the Z axis. But the problem is that when you're coming down to where you're cutting it out of your sheet, like let's say if we turn the stock on, you will see that at some point we're going to machine all the way down, and we would like some tabs on it to hold on to everything. So then the tabs are kind of like just in the end, you can break the part out. The ramp toolpath is actually not the best for this. The best toolpath you want to get there, Casper, is go in instead. What I would do is I would go into the 2D. I would select the 2D contour. We can leave the same tool here, and then we're just going to select an edge, so we can just select around the edge there of the part. And there is actually in the passes tab, you will find that in here there is a no, not in the passes tab. In the geometry tab, there's a tabs function. If you turn that on, you will actually see the tabs appear. And you now have some control over these tabs, so you can make them wider if you want to. You can make them a little bit thicker if you want to. You can position them. The differences in here. So if I make them smaller, let's make them 25. It will actually distribute more tabs, so you can kind of see those. And what the toolpath will do for this here, we will turn the depths on. Step down depths. I'm messing up between metric and inches here, but so what it will do if we zoom in is when it comes down to the last pass, it would actually kind of like lift over and leave those tabs on there, and then you can break it out. So the RAM toolpath is kind of cool, but it's under a 3D toolpath, and I'm gonna come back to that later. I would actually switch over, Casper, and use a 2D toolpath instead. Now the 2D contour toolpath will do a lead in, lead out on it. The ramp will not. So the ramp will kind of like never do that compensation. But yeah, that would be my favorite toolpath for that. Would be the 2D contour toolpath. Hope that makes sense. Hope that was useful. Casper, 1, 2 down. Next one. This is from Kim. It's Sunday afternoon. I'm live. I hope the connection is good. Thumbs up if you like this. Thumb down is thumb down if you don't like it. That's okay. Leave comments. I love the comments. It should be live on Facebook. It should be live on YouTube. It is also being recorded. And I'm gonna do what I've been doing the last couple of weeks with these. Is I'm gonna chop up and find a couple of best ones and fill them out through the week. This is just me trying to answer some of my emails. With the new role at Autodesk, I'm so busy during the week that I have a hard time keeping up. So that's what this is. I hope you're doing good. Hope you are enjoying your Sunday. All right. So, and I'm just going for an hour or so here. Kim asked, I got into 3D printing. Haha, me too. 3D printing right there. And struggled with a few design programs. Well, yeah, we've all been there. Don't worry about it. Like Fusion 360, that's awesome. Now, I watched your LarsLive 102 about components and bodies. Yes. So let's just go in and just clarify what we're talking about. So if you go to YouTube and you type in, I think you can just type in LarsLive and let's do 102. Click on that and you will get LarsLive 102. So this video here, look at this. I didn't have any lights in talking about bodies and components. So that is definitely out there. Now, when Kim watched this one, my timeline includes everything for every component. I started fresh. I made a few components, but my timeline keeps on being like bigger and bigger and bigger. I've tried some different components. Maybe it's a setting or something like that. Let's take a look at that, Kim. Let's get back into Fusion 360 and let's talk a little bit about this. So I'm just going to start a new file here. So an empty file. So let's just dial it back, just two levels back, just so we all are aware where we are. So when you're inside of Fusion, so this is a completely empty model, you have a timeline down here in the bottom. And that will be populated with all your sketches, extrudes, and things like that. Over here in the left side, we have where we will have our bodies, our components, and different things. Now, I will just say that if you don't see this timeline, sometimes you will not see this timeline. You could turn it on and off. If you right-click up here, you can choose not to capture the design history. I'm going to click on that right now. And now you will see I don't add history line. This is great if you're working with imported models and stuff like that. But I would normally recommend that you always have that turned on. Capture design history. So you have this history down here. All right. So let's get into talk a little bit about, Kim, about how this works and what you can do. So right now, I just have a component in here. And if I go ahead, so you can see this is just one part component. If I go ahead here and open up a sketch and click on that sketch And let's hit my S key and find my center rectangle. And I'm just going to do something that is 100 by 200 millimeters. Just a sketch. Finish that sketch right there. Now we will see that down the history tree, we have this showing up here, right? So that's just a standard sketch. Now, what we can do is we can go up and we can say, I want to create a component from here. Say I want to create a new component. Click on that. And as soon as I do that, you will see that this icon changed from a single white square to a assembly file. And you can switch between the two views. So now you will see this is component number 1. And you will see it has, I call this the little fisheye. You'll see down the timeline there's nothing. Now if I go back up to the top and I activate that fish component, then my sketch comes back up. And you will now see that anything that happens from this point and downwards is now assembled down the timeline. So I have the first sketch we created, and I have that new component we just created. Now again, if I switch back to the fisheye, notice that the component has nothing in it yet. Now what I could do was I could go ahead now with that component activator. I could go in here, click open a new sketch. Okay, now you will see the edge of our original sketch that is up here, up on top of it. But we can't actually kind of use it right now. But we could do it, hit P for project. If I double click on this edge, I'm just going to select that sketch. Now I have copied the original sketch into this new component. Remember, we have that fisheye active. So now we have that sketch. And what I could do here was, I'm going to hit a center rectangle. Just going to draw a rectangle out. Let's make it 10 by 10. Something like that in there. And I'm going to do that 3 more times. Let's go up here. These out there. Hit D for dimension. And then I can actually just click on this. So you see that's D3. I can actually just click here, place that, D3. Click here. D3. So I'm actually just copying this 110 up here into the rest of them. So now I just have to change, if I change the D3 dimension, everything will update. This goes a little bit too fast. You can always come back and watch the recording later. But what I essentially have done right now is that if I change this one to, let's say, 15, you will see everything updates to 15 in here. Except this one. Why? Because that got its own dimension. D3. So now I just made that whatever I change this dimension, then everything else will change with it. You see that? Huh, that's a lazy man to do that. Still inside of component here, I'm going to finish that. I'm going to hit Q. Now I still have that component active. And I'm going to select our 4 pieces. Write that down, minus 70. And now inside of component number 1, I have now created 4 legs. And you can see we have the sketch, we have the extrusion. Just slow left click, I can rename it, leg. See that? So we got legs. Now if I go up and click on the top one again and make that active, notice that it sees everything. So the top one will see everything you create down here. Now I'm going to create one more component. I'm going to right click, I'm going to say new component, and I'm going to call this one tabletop. Tabletop. You will see again that there's nothing inside of this one as I created, but I could do what I did before. I could open a new sketch on the top face here, and I could hit P for project, and I could double click to select that whole thing around there, hit Q for press pull, and we could do like a tabletop like that. Now you will see those 2 extrusions in there. We can go up and activate the legs, and we will see there's the 4 legs. Or we can go all the way up to the top, and you will now see that we had our first layout sketch, the first sketch I created. We then had the component creation, a sketch and an extrusion for the legs, a new component for the tabletop. So this one here will always have everything in it, except when you start diving down into components, then it just narrows it down into the components in there. So that's the one thing I wanted to show you about this. Now, you might be asking, why did I do that original sketch? Because that is actually controlling everything right now. If I go in and edit this one here, and I made this one 50, you will see that everything updates in here on that original sketch. That original sketch is driving the sizes of this. So that's why that is kind of handy. Now, so you are right, Kim, about that these down here gets extremely long. What you can do is you can group them together down here, but you can only group in a certain order. What I mean by that is I can take these three were created belong all together. And by the way, if I click on this sketch, notice how it actually shows with 3 lines that component it lives within that body, right? If I click on this sketch, you will see that lives within that body. So you get that indication when you click on a sketch. But what I can do is I can actually click on, if I hold down Control and I select these 3, they all kind of like belong together. If I right click on them, you can create a group. And when you do that, they all kind of like gets grouped together in here. And you can hit the little plus sign, you can expand them, you can hide them down like that. Same thing, I created these, everything in an order. I created first the component, then I created the sketch and the extrusion. I can also select these 3 items, hold down Control, select the 3 items, right click, and I can group those together. So that's one way that you can start kind of ordering things together in this timeline. But you gotta be a little bit aware of it. If I right click here and say delete and just get back to where we were before, you will see I cannot select this component and these 2 and group those together because they don't associate it. But what I have done, I did a plastic injection mold totally inside of Fusion. So if you go up here and you do search on Google, not on Google, but on YouTube, injection, Fusion 360. I did this series here, Fusion 360 Tutorial Beginner to Advanced, how to create a mold. If you watch that video, I'm pretty sure that in that video, in the end, I actually took like things like fasteners down here, and I started grouping them together. So that's one way you can kind of clean this up with this. So I hope that was useful, Kim. So you can kind of start grouping it up. This also is an interesting topic that maybe is worth for me to mention. Here on a Sunday. Hope you're doing good. I think we're live. I hope it's not choppy or anything. If it is, then if it is not worth watching, just jump off and I'll make sure the recording goes up there. But one of the things about Fusion is that if you're looking to create like hundreds and hundreds of components inside an assembly, you're probably looking for more like something like Inventor than Fusion 360. So Fusion 360 kind of do that timeline all the way in the bottom and don't let you break it up because it has some powerful functions in it. But it can, if you start getting hundreds and hundreds of components, Inventor is probably handles that a little bit better than Fusion does. I heard something, what was it? In Inventor, they opened like an assembly with like 1 million components in it. Whew. All right, let's move on. Thank you, Kim. I hope that answered your question. Next one here is from Nathan. Nathan is asking, first of all, I want to thank you for the time and the money and the efforts. There's not much money into this. Autodesk bought the equipment. My time on a Sunday, it's not that expensive. Appreciate it, Nathan. Talking about doing like a cube, like a Rubiks Cube. I actually have that. I did get that image in here. Nathan sent me this image right there. Trying to do a Rubiks Cube. So Nathan watched last week's LarsLive episode number 2, where I did a toggle clamp, and we brought that in from McMasterCarr, and we talked about how to make things move. So Nathan is trying to do that same thing with like a Rubiks Cube, and it's a pretty cool image. But running into some issues with contact sets. And you know what, Nathan? I think that will be an issue. Honestly, I don't know a great way to do that inside of Fusion 360, because when you think about a Rubiks Cube, I don't have one here, but you know, all the movable function that can move all different kinds of ways, that does become a lot of movements. And I think you're thinking about it the right way, really, to think about like contact sets. But the problem is that Fusion as a mechanical CAD software is not really meant to simulate all those different movements. Maybe it's easier if we jump into Fusion here for a second. If we, for example, went into Fusion, and let's just do a cube here. S key is center rectangle. Let's do, I don't know how big a Rubiks Cube is, 200 by 200. Let's extrude that. So Q for press pull. And I have my perspective with all the faces on. And let's go symmetrical. Let's go 100. So then we kind of like have this cube here. If I did a body split of this thing, split that with that plane right there. So now we have two bodies, right? Of course, we can't make movements between bodies. We have to turn into a component. So we can right click and say create component from bodies, create component from bodies. So now we turn those bodies into components. Now they can kind of moving around like this. So what we could do was right click and ground one. And then we could go in and use that same function I actually did last week. What is the as built joint? Select this one, and then turn it into the revolute kind of function here. And you kind of have the movement of the first ones, right? Like half of it. The problem with the Rubiks Cube is that the Rubiks Cube, of course, has a lot of movable functions in it. I mean, it's a fairly simple layout, but when you start thinking about it, inside of it, there's a lot of different movements in there. So what I would do if I was going to invent a new Rubiks Cube, I guess, and I wanted to design it inside of Fusion, what I would do would be that I would design it with all the cuts and sections in there, so all the different components. But when it came to actually, you know, if you had to create a 2D drawing from it, where you have to show, like a 2D drawing, where you have to show the movement, I would just have movement on some of them. Like place one of them like this, and then kind of show that it can move around. But I would not, if I was going to design a Rubiks Cube, I would not use Fusion 360 to actually make the real, you know, movable simulation in there. Mechanical CAD software like Fusion is just not really meant to simulate these kind of movements. If you're using something like you know, the design and manufacturing collection where Fusion is in and Inventor is in, there's other really great tools in there to simulate something like this. But yeah, you could definitely design it, but for all the different movements, I wouldn't have them working on all of them. Hope that is useful, Nathan. Hope that's useful. Hope this is good. It is Sunday afternoon. We are live on Facebook. We're live on YouTube, and I'm just cleaning up my emails here, answering some questions. All right, next one here is from Triam. Triam, dear Mr. Lars Christensen, dear Mr. Triam, good day, sir. Good day to you. Mechanical engineer from the Philippines. Oh, cool. Relatively new subscriber to the YouTube channel. Absolutely appreciate it. And I just want to let you know that I appreciate YouTube channel tutorials and you're learning something. Hey, that's awesome. Cool. Not much to answer with that one. Thank you, Triam. Really appreciate you watching these videos. Really appreciating all of you guys taking the time to watch these videos. If it's good, thumbs up. If you're not, thumbs down. Leave those comments. Love those. Next one is from my buddy David. I just wanted to share this one here. So if you remember last weekend we did let's just go to the channel here. Go to the YouTube channel and let's go. I think the title is wrong on this. I gotta find out why the title ended up being like that. We'll change that. If you go to last Sundays in here, in this one, we modeled up this thing. Remember that? We modeled up the chain in here, and there was a rope around it. David, who has always been good at sending me his versions of things, sent this here. So I just wanted to share that. Thank you, David. So he modeled up this this rope. It's kind of cool. I think he used, I would imagine, I didn't see the file, but I have a feeling that he probably used the coil function maybe to do that. So that is kind of a cool image. Wanted to share that. All right. Next one. Next one is from JC. JC, love the videos. Thank you so much. So my question is, how can I get threads into a part from McMasterCarr? So this one I think was kind of interesting. I wanted to share this one. I have a couple of images. So we have this from JC. What is some male threads on some parts that could be downloaded from McMaster, right? But now I want to get that thread into maybe some other parts that don't have threads. So you can see that in here. So there's some cool, neat tricks you could do that. One way to do this. Let's open up a new a new document here. So we can go to McMaster, insert, go to the McMaster here, and of course you can search things in here. And I was kind of picturing if we search something like a metal pipe thread in here. There's some, looks like there's some threads on these models. Span that out a little bit. Let's go down and find something. A 3/8 pipe. Select something that is 6 inches long. If you click on this product detail, then you can go down here and you can save it out as a step file. Hit save. And it's just going to take a second. And there it is. So there is this file here from McMaster. Now it's important, and this is actually pipe thread. So somebody's going to yell at me now and say, when is the pipe thread coming inside of Fusion? So this one already have pipe thread in it. Now let's have some fun with this and kind of like say, what if we modeled up a cap and we wanted that thread inside of it? So if I go up here and let's open up a sketch on the side here. I'll show you something neat. Hit C for circle, and I'm just gonna steal the edge of the inner side here, right there, and then I'm also going to draw a circle, Z for circle, and just do an outside kind of size for the cap here. Let's make it 25. It's a big cap. Now here's a neat thing. You see how the purple line circle in here is the inside of the threaded hole, but the outside here is the outside cap. Did you know that if I go ahead and hit press pulse or press Q, that if we select this area here, now if I do this, you will see that it kind of starts cutting from that spot. But did you know that you can actually choose a start profile over here? Actually offset that start profile. So if I, for example, went out, I don't know, 50 millimeters here, then it's not starting this area until here. Now I'm going to make it a new body instead. So now we kind of have that starting right there, but it's still a little bit too far. So let's go, let's try, where's 75? 70, getting closer. 65, that's probably good right there, right? So we can see how we kind of have that going for us right there, like that. Draw that back there so you can see that's a nice little cap right there. So I'm just gonna, I know people's gonna yell at me. Let's put it right there. Hit OK. Now I made that as a new body, so that has its own body. So there is our first body. Here's our second body here. We could actually turn it into a component. But what I'm gonna do is I'm just gonna finish it up by go ahead here and select this face here, and I'm gonna hit P, select this edge, Q, and select here, and just give it, it's gonna be a closed cap, right? So now it's a closed cap, but if I hide this body, we will see that there's nothing in here. Let me just go ahead here right now and make that a component. So we have the two different components. Here's our cap, and then here's the rod. But there's interference between the two. The cap don't have any thread in it. Now what you can do is you can use the combine to do this, but it's a little weird, but you can. If we click on that, and we will select our target body, what's going to be our cap, and then our tool body is going to be the imported McMaster. And if we do a cut, it will actually cut with that. Now, if I just hit OK right now, we actually lose our McMaster. But if you check this Keep Tools, like this, then you get to keep it. And now if we hide it, you will see we got that thread right in there. How about that? So we just literally made that cap, and we got that thread in there. Now, I'm saying that, and then it's quickly that I quickly gotta put in my disclaimer kind of thing that this is my and nobody else's opinions. Now, it's important to know that that thread that we just created is an exact copy of the male thread, right? We had the male thread on the McMaster, the screw part, and now we just made the cap, but the cap has no clearances in it. Normally when you're doing threads, something like the Machinery Handbook that I brought down from my shelf up there before in some of these videos, you need something like that to get the appropriate clearances in there. So what I would suggest doing would probably be to either, depending on what you're trying to make here. Now this is all steel, supposed to be steel, so you would actually have a tab. You wouldn't be using the model thread directly. But I guess what I'm getting at is that normally when you're doing something like threads, there's clearances in there, there's thread specs, so use something like the Machinery Handbook will help you with that. I hope this was useful. You let me know if not. All right, let's move on here. Paul sent me an image. As a practice, I'm trying to duplicate some electronic enclosures in sheet metal, and I quickly came across a problem. I was able to make the hem edge, but it should be bent 90 degrees. All right, let me just show you what I'm talking about here. Open this up. This is from Paul. So, this is a sheet metal enclosure, and there's a hem, and Paul says that, I was able to make the hemmed edge, but it should be bent at 90 degrees afterwards, such as the bottom and the side of the enclosure, what I believe is when we're looking kind of like on this 90 degree in here. That's a photo of what I mean, and that's a good photo. Since the metal has to bend in two directions, I don't think that Fusion can handle that. Am I missing something? I honestly don't think you are, because I don't think it. I agree with you, though, that I did not ask any sheet metal experts on this. So if we go in here, so I might be wrong. How about that? And we did something. Let's make it. That's gonna be a little hard to do when I part here, huh? Let's go in here to sheet metal up here. And let's turn this into a piece of sheet metal like this. So you could go in and do a flange up like this. And I know that you can turn that somewhat into you can go in here, and when going in here, you can actually override the rules. So if we go in here and make the band tiny like this and make this tiny, I don't know what tiny really is here. Let's make it 6 and do another going down. Let's override the rules for that. So you can see here that I'm able to do, with the override rules and changing the bend radiuses in here, I am able to create that ham, right, something close to a ham right there, and that should flatten. And it does. So that flattens. But the problem where I think we're running into is that if I just go backwards again, like this, when I go in to create one like you have there, go up 100, you run into an issue with how it's handled here, because it will actually not let you do what you're doing on the picture, where you are actually not splitting, you're not splitting the edges. And I think just because Fusion is, this is meant for like heavy gauge steel, that it wants to break the edges down, and that way if you wanted to create hams, you can, but you can't get them to roll over two edges like this. I would say like this, Paul, that if you want to go further and you want to get somebody else's opinion, I would probably go out to Google and I will do Fusion 360 forum, right? Go to the forum. There you will absolutely get the smartest people. They're a lot smarter than me. So there might be somebody right now watching this video and say, oh yeah, you can do that. I have a trick for it. But of course, this is Lars. I don't know everything. That is for sure. So go out to the forum and check that out. That is probably a better option. Thank you for the email, Paul. Sorry I didn't have a solution. That is kind of one of the defaults with me sitting here on a Sunday. Just got back from San Francisco yesterday, so I didn't really have time to spend a lot of time trying to investigate this. This next one is from Hardy Jones. Thank you, Hardy. Hope things are going well. Things are going splendid, man. Things are awesome. I think we are live on Facebook and YouTube. People are commenting, what is awesome. People are thumbs up. That's awesome. Really appreciate you guys taking the time. Now, here's a question. I'm trying to design a gear reduction to turn an old hedge trimmer into a powered hacksaw. That sounds like a cool project. So you've used the spur gear scripts in Fusion 360. Yes. So if you didn't know, there is actually, if you go in here and type in Fusion 360 and you do add-ons, you can actually go here and you can download all these cool apps that can do all different kinds of things. And one of them is a spur gear app. I used to have it. I haven't had it forever. But there's some different spur gears. Now the question that Hardy has is, after I get those gears created, can I continue modifying them? Yes, you can. You will use the direct tools, and the best way, I'm not going to go in and try to show that right now because it's going to take a little bit of time. I actually have a better option. If we go back to my channel here, down here, if you click on the video that is called How to Modify SOLIDWORKS Files Inside of Fusion 360, that will give you, it's a 9-minute video, it's not very long, but that will give you all the different tools there is in here where you can actually continue working with files after you have after they have become solids. So check that out, how to modify SOLIDWORKS files, and you will learn about all the direct tools where you could modify this. So I hope that was useful to you, Hardy. Next one. This is from Axel. Hey Axel, how you doing? Hope you're doing good. Axel sent me another image. Let's go in here. Axel would like to know, how do you use something like a T-slot cutter to cut a T-slot in like a CNC mill table? So let's do that. Let's get out of this stuff here, get back into Fusion. Come on, Fusion. And let me show you that. So first thing we're going to do is we are going to model, we're actually going to design our own cutter. You can do that inside of Fusion. So let's try that. So I'm going to go in here, create a new sketch. And I am just going to try to draw this up without too much brain power. I'm going to make a 10mm shaft. I'm going to make the cutter 100mm long. And I'm going to do another rectangle here. It's going to be a T. It's going to make 10mm up. And then let's make it 25 wide right there. Now I actually probably would trim this up. So let me just delete these dimensions for a second. Here. And let me just go into the trim tool and just get rid of those. And then I will probably redesign it. So like that there, and the shank. So what I'm doing is I just designed it the way that I probably would measure the cutter. Now this is only half of the cutter. So this is actually it's going to end up being a 10mm slot that can actually cut in 25mm from center, but that actually means that it can only be a 15mm deep slot. But we sketched this up as a sketch. So this is how you can draw up your cutter. And make sure when you do this, Axel, that make the origin be right there where the center of rotation is. Actually, the easiest way to do it is actually to do it the same way you would do it revolve. So if I did a revolve, select this profile and rotate it around that center, right? So that's a T-cut slot cutter right there. I'm going to get rid of the revolve there again. This gets back on. So what you can do is that if you go into your manufacture tab, and if you go up underneath the manage, you can click form mill right up here. Click on that, and you will select your tool profile. It will kind of like be the same thing as we selected before. And the axis that it's going to spin around on, and make sure again that that's the origin right here. Make sure the arrow is pointing down. You can flip that up and down right there. And then you actually get to select a compensation point. What is where the cutter is going to compensate from. And I would probably select that lower corner right there. Hit OK. And when you hit OK, you will see right now that nothing has really happened, except if we go up to the tool library. Right now, inside of our open file, this is the file we have open right now, we have a 50mm form end mill in here. Okay, now it's only inside of this file that we have open, untitled up here, that hasn't been renamed. So what I would do, under your local library, right click, I know that's a lot of instructions here, new tool library, let's call this one Excel, because that's your tool library, Excel. And then I will go back up to our document that is open right now, and I will drag that into Excel. So now I will click on Excel. We now have that form tool in there. Now it's saved. Okay. Now let's open up a new document. Let's open up something here. Let's make this 200 by 200 like this. And let's extrude that. So we're just extruding a block out of steel. Like that. let's go ahead and create a sketch on that, and somewhere in here we're gonna make a 10 millimeter slot, and it can only be, well, it could only be 15 millimeters, so let's make it 12 so we don't crash anything. And up to the edge there, let's make it 15, and let's cut that through. Q. So now we have that slot. Now, if we go into our manufacturer, set up, it's fine. And let's do a 2D contour toolpath. There you go, Axel. Select that inner edge. That's the same edge where I had my my compensation point. And let's go and select that end mill out of Axel's library. There's the form end mill. You can see we get a view of it there. Hit OK. And if we did it right, then we will see that that is T-slotting right down there. Let's send the stock off so we can see it again. So there's your T-slot cutter cutting out that opening right there. So that's how you do that, Axel. If it went a little bit too fast, rewind back. That's okay. Watch it a couple of times. Have a drink, whatever you need. And hopefully that's useful. All right, let's see here. Do I have a time here? We've been going for 51 minutes right now. We'll go. We have more to go. We'll go a few more. Next one is from Jonathan. Hey, Jonathan. Thank you for providing a ton of resources to hobbyists. You're so welcome. This is relating to this. I wanted to know if I can keep track of end mill usage somehow. Does Fusion provide a linear length of a cut so you can kind of figure that out? That's a really, really good question. I like that a lot. You do have a linear cut within this. There's actually a couple of different ways you can do that, but there's actually an info tab over here, and that will show you. It will show you the start and the end position, and it will show you the time being engaged in here. And you will also see the machining distance for this one here. There's your cut length. So for this one tool path that we just simulated, right there, you'll see there's a machining distance of 693 millimeters. So there is a way for you right there, Jonathan, to go in and check that out. You will also get all the tool changes in here. Now, with that said, I think if we go in here, I think it will also show up in your machining setup sheet. It can show up there. There's a machining time that will show you that feed distance too. So you could go into all your different tooling operations. So if we go back to like one of the first ones we did in here, we could right click here and say machining time, and you will see the machining time in here with the feet and speeds. And in here you will also see the total distance that it's fed. But another thing I wanted to just show you that I did, so I'm kind of like going back to my days at Ridlam. If you go out to Google and you search macro B programming, and let's go to images. All right, this book right here by Peter Smith. This book is done by Peter Smith. It's FANUC CNC custom macros, but it's not just for FANUC machines. You can use this one for a lot of other machines out there. This book is one of the best things you can absolutely buy if you're ready to take your CNC programming to the next level. So what I actually ended up doing when I was at Ridlam, now if you're just a hobbyist messing around with like a little table CNC machine, this maybe is not something you want to get into. But if you're like a professional CNC shop kind of thing, and you have not explored macro programming already, that book right there from Peter Smith, and I'm not affiliated, is one of the best books you can, and it doesn't have to be for Fanuc, it can be also for Haas's and other ones. So what I ended up doing at Ritlam was I actually created my own macro thing where I could keep track of all my different tools. I used it for like breakage, so I could like set counters in there, how much the tool had been used, and you can do, the world will open up for you. So Jonathan, that's my recommendation, that if you are looking to getting into figuring something out about end mill usage, buy that book. I know a lot of CNC machines already have things like this in the control of them, doing something in the background, like I think the Matsura has it and other machines has it, but this here, that macro book is phenomenal. Peter Smith, check that out. All right, next one here is a question from Jeff. Autodesk is getting rid of the 123D slice and created a slicer app for Fusion. I can't seem to get it installed. Maybe doing like a Viking ship and things like, and do a slicer. All right, so let me just show you this. So maybe I was showing before that there is the different apps. There could be a slicer app out here. I actually don't know if there is anything. So there is this slicer right here that you can go, and you, doesn't look like it's supported for, or maybe it is supported for both. You just have to be on a Mac. So there is this slicer program, but I don't think that I think that you're looking into 3D printing in there. There is actually inside of Fusion now, if you go up and click on your name and you go to preferences and you go to extensions, there is an additive manufacturing extensions. However, this is a trial right now. I know that they're changing a bunch of things, and this is not really meant for 3D printing like what is running in the background in my office right now. For the Ultimaker, this is actually meant for metal 3D printing. So if you go and select in manufacture and you select the machine, you can actually select an additive machine in here right now. But right now, as far as I know, and I haven't, maybe go out and do some forum posting, it's only for metal 3D printing right now. It's actually some of the NetFab technologies are coming into Fusion. I think there's going to be a certain cost associated with this because this is more, again, like professional and not meant so much for hobbyist printers like me with my Ultimaker in the background. But it does have some supports and things like that. I think there's a blog post out there about the this whole extension preview thing. I could be wrong. But I would say this, so this is definitely something to keep an eye on. It's coming. But again, right now I think it's most for metal 3D printing and not for plastic. I will say that my good friends from Ultimaker, has the Cura. And as far as I know, the Cura slicer is free of charge. So if you go to a Cura Ultimaker, you can download this one. It's shareware. You don't have to have a license in here. You can just get the Cura, and that will do some of this stuff here. And the reason, just to kind of like dial back a little bit, one of the things that is happening with Fusion 360 with these extensions is a way to kind of like trying to make it more professional sense from a manufacturing standpoint. So Fusion is really going to become, as far as I know, and I don't know much, but to my knowledge, it's going to be a lot more manufacturing oriented than design oriented. So taking these extensions from PowerMill, from NetFab for the metal 3D printing is coming in there. It's super exciting. That's what they're kind of working towards. So I think that us hobbyist 3D printers, like this one running right there, we probably have to use something else. I don't think that they're gonna put that in there, but Cura can do it. I've used Cura. Cura is cool. So hope that was helpful. Jeff, all right. Next one here. It's another cam one. This is from Nishesh Singh, maybe? How to pronounce your name? Sorry if I mispronounce it. Thank you so much for sending this out. This is just, again, what I'm trying to do is just a little bit of attempt on adding some value, going through my emails. So this one here is 2 questions. A bit unsure. Number 1 is, when do we use the pocket command, and when are we using the adaptive clearing? So again, this is cam. And when do we prefer 2D operations versus 3D operations? I can definitely answer that one. So let's get into Fusion and open that one up there. So let's just draw something up quickly that could be both. So hit the S key on my keyboard, and let's do something that is 200 by 200, like that there, and let's do O for offset, and draw something up like this, and let's hit Q, and let's just draw that up there. So now we kind of have this area here. We could do another sketch on the background, hit P for project, select that. Whoops. What did I just do? So like that there. Q. Give that a little bit of a thickness to the bottom. All right. So for cam, when do we pick between a standard pocket command and a 3D or an adaptive? Well, it's 2 different tool paths. So if we're just going ahead here, and we do a 2D pocket, for example, click on that, select that bottom edge down there, let's select the tool, let's go to metric, select the 16mm end mill, like that, and let's start machining this. And we're gonna have to turn some depths on here. Let's go in and select multiple depths. That's fine. Okay. So, if I go in right now and I simulate this, turn the stock on, and we start simulating these cuts here. So you will see right now, as it's machining right now, that it's just literally going out. It's not taking anything into consideration. It's just going out from the center. It's just working its way out in straight lines. See that? Then it goes back in again, goes down a little bit, and then it's just following the same tool path, the blue lines. I can turn those off. And you can kind of see that it's just following, it's cutting rectangles, right? Or squares. Just following that line, square, 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 square. Okay? Now let's stop that tool path for a second. Let's just go in and suppress it. So then it's like it was never there. Let's go in and select a 2D adaptive clearing. And select that same area, same tool. And let's do multiple depths again. Now, I'm going to let this one go 5mm deep. So it's going to go a little bit deeper. I'm going to show you why. See how the tool path looks different right now? So let's go ahead and simulate that one. See how it goes down in a circle, and see how it goes out and out in a circle, and out in a circle, out in a circle. Speed it up a little bit. Until, speed it up too far. So it's just going to go, I can't do that. Dang it. Okay. Goes in a circle. And then suddenly now you will see that it starts changing, and it just gouges out the corners, all 4 corners. So it's not doing a continually square out. Now, the difference between the two is that one is old-fashioned and the other one is new. And the adaptive clearing is the newer type of toolpath. See, what's happening here is that when we're cutting with the adaptive, we're going down in depth with the cutter, and then when we are down with the depth, in this case is 5 millimeters, then when we start cutting out, see how it's kind of like doing, I call it fishtails, but it's kind of like doing a corkscrew out. Right now, there's only pressure on the cutter in that area right there. It's side milling. There's no pressure on the sideways on the cutter on the bottom. That's adaptive. Where when we go and unsuppress, switch these two around. When you go and look at the other tool path, and we simulate that, it's going to go down to a depth, but when it's going out in these movements here, look how much pressure there is on the cutter right now. All around that whole circular edge. It's literally like what we will call slotting in CAM. So right now this tool path is just slotting material away, what is really hard for the cutter. And therefore, we can only take very small step downs because literally the whole cutter is kind of slotting right now, right? Where with adaptive, you're only side milling, and that means it's a lot gentler on the cut. So to rough material out, to get the material out of the way, I don't know if I'm doing a good job describing this, but the adaptive, when you're roughing, is much gentler on your cutter. You can actually remove a lot more material like this faster and be a lot gentler on the cutter, because at no point, as soon as it got that to depth, will it ever slot again. It's only taking a certain amount of the end mill, and it will never slot. To the fact that when we get out to the edges of this cut, you will see that when it gets to where it starts cleaning out the end here, it never slots. It still only kind of like does fishtails out to remove that. So adaptive is a lot more gentler cut on your cutter versus a pocket tool path. So when would I ever use one over the other? What I many times will do is on the adaptive, I will go in and I will have stock to leave turned on because I'm just roughing a lot of material. And then you could use the 2D pocket. If I drag it down here, if you go in and we unsuppress that and we edit it, you could turn stock to leave off down here, turn the multiple depths off, and then really just use it to clean up the bottom. Then I wouldn't have it spiral all the way down to the bottom, of course. Go into the last tab in here and just plunge down like this. So now then I would actually have a roughing tool path that would rough all this material out, very much gentler than a pocket tool path will do. And then I would use, many times what I will do is I would actually do a contour tool path for my sidewall and have that being a multiple depths. Let's say we made that 10 millimeters, and I would have stock to leave on the bottom, but not on the side. Like this. So now what I get, put that right there. So I have an adaptive. This will rough all the material out. It will leave material on the sides and on the bottom. Then I would come in with a contour tool path and just clean up the sides so they get nice. And then in the end, I would come in with the pocket tool path just to clean up the bottom, get that to size with that. So adaptive clearing is a great tool path to get rid of a lot of material Actually, it's the best toolpath to always get rid of material. Even if you only had to move a little amount, I would still use the adaptive because it's a lot better on your tool than the standard. I hope that was useful. The other question was when to use 2D versus 3D. So you saw here that for here I only used the 2D. The 3D toolpath are really only great to do when you have what I call, people hate when I use this phrase, swoopy surfaces. So when you have like curved surfaces where you need the tool to kind of move up and down over something, then the 3D toolpath will be better. So if you're just doing like things here, what is pockets, machining pockets out, drilling holes, you should find everything you need in the 2D toolpath. I hope this was useful. We're a little bit over an hour right now. It's just a Sunday. Trying to get through some of my emails. Hope this is okay. Hope we're streaming on Facebook and YouTube. I think I have the wrong title on the YouTube. That's what happens. Kind of going off the cuff here. Next one. This one I definitely want to show you. This is from Brad. So Brad, awesome. He watched last week's live stream. He was talking about the sheet metal function and using the bend feature. So if you are curious about that, we kind of were talking about how can we get holes into a part like this and still go up and flatten the dang thing like that. So we showed that last week. So I just wanted to show this because I thought it was too dang cool. Brad sent actually an image of what he was trying to do. So he kind of got that all figured out. It looks absolutely awesome in there. Brad, nice work with getting all those chains in there. So that was kind of cool. So hopefully, you guys finding some useful through these different live streams. All right, we only got a few more to do here. Jim sent an email. Hey, Lars. Hey, Jim. NASA has made elevation data for the moon available on the web. Is it possible to migrate the spherical elevation data into Fusion, create 5-axis cutting toolpaths from it? I'm a software engineer and can do a lot with prepare files from other formats. You probably can, Jim. You probably can. But I think you're pushing again a little bit about what you can do with Fusion 360. Again, Fusion 360 is based on mechanical CAD. Now, I'm not the guy to tell you can't do something, because whenever you say something you can't do something, it's always somebody should prove you wrong, right? But I will show you that might be useful if you're getting back into the YouTubes in here. I did do a we're going to the live stream, 100 live streams in here. Let's kill that guy for a second. Pause him. Let's go into the list here. There we go. And in here you can do a Control F and you can search. I probably have to make sure that I get down. But if it's like STL files, that's definitely more than 3. Make sure we scroll all the way down here. Update. There's 198 in here. There's definitely more. There we go. 7. This one. How to handle large STL files, smooth surfaces inside of Fusion. So this one here, live stream 169. Go and check that one out, Jim. You can bring in, if you can bring in the scan data into Fusion of the moon, because the reason here you can see that I used kind of like a globe in here. If you look through here somewhere. Maybe I never used anything bigger than Mount Rushmore. But if you can bring it in, you can chop it off in here. You can play around with it. You might get it to work. And you can actually, inside of Fusion, you can actually, I'm not going to show it here, but you can actually do, with the 3-axis toolpath, you can do a scan data. I did a live stream on that too. One of these in here. We go back where we just were. So this was live stream number 169. Go and check that one out about bringing in big STL files. And you can actually machine an STL file with tutorial 119. That might, and you can, inside with that, you can actually turn on tilt, what will do 5-axis. So I would say, yes, probably. It's probably not the video I'm going to do, Jim. I'm sorry. You can give it a thumbs down if you want to. All right, next one here is from Jake. I thought this one might be a fun little modeling exercise. So Blake sent me some really cool images of some airplanes that some of his students are doing. So we have an airplane image right here, and we have also the sculpt environment in here. And it looks like, when I'm looking at this, we're inside the sculpt environment. You can see we have all these T-spline bodies. And then in here, we have a lot of bodies. Now, if you're looking down at the bottom, we'll see there's a lot of red down here. What tells me, Blake, that probably trying to, some things are not working in here, and that might be part of the issue. But I thought at least I would give it a go and see if this will help you, Blake. Maybe it will not. But if we go in and we create, go into T-spline, and let's go in here and just draw up a body here. So this is going to be my fuselage, like this. And if we hit OK to that, did you know, by the way, if you right-click and do the edit form, double-click here on the edge, now I can pull in it. But did you know that if you hold down Alt on your keyboard and then pull, you have to bring in new sections out. This is how you can add new sections in here. But it's kind of a neat little trick. Now, in here now, we could start to kind of trying to make this into somewhat of a fuselage. Now I'm just playing. Right, so that could be kind of your fuselage right there, playing around with this. Now, if I just hit OK right now with this, and this goes back to I think it was last week's live stream. This here right now is just a blanket. There's no thickness to it. Now, there's a couple of different ways we can do things. We could go in right now to the Modify tab and say Add Thickness. And if I select this and I add some thickness to this, 10 millimeters. Now you'll see that it actually has some thickness to it. It's still hollow inside of the center on this thing. Uh-oh. It's thinking. Hang on a second. Uh-oh. I just killed Fusion. Oh, this is great. Okay. This is what happens when you get 8 windows open inside of Fusion and you're trying to live stream at the same time. It happens to me too. We are about an hour and 18 minutes in if you're watching the live stream. So it's a Sunday. I'm just trying to get through some of my emails. And we can actually recuperate a lot of the ones that we had in there. I don't know what the last thing it saved was. I should have saved all these as I was going through, shouldn't I? Alright, let's see. Recover documents. This is why you should save. Oh, that's the last one it saved. Alright, so I'm going to have to do this again. Let's go in here and do another one. Right there. C for circle. And drag it out. So what I was going to show was, so I did the kind of like I did do the fuselage kind of thing. Like that. That if we go in and we use that thicken, I'm going to try to make it a little bit smaller. Like this here. Now it's thick. And if I go in now and I say finish form, then that would actually be a body. Right? I hope you got this far, Blake. Now, if I go back in again, and I'm doing this just to show, now I'm making another body in here. And let's Let's go ahead and do the same thing again. Actually, let's go ahead and do that same shape on this face here. And let me try to just draw a smaller circle like this. Let's do symmetrical. Drag that out there. So this is gonna be my it's gonna be my wing, I guess. So let's do symmetry like we did last week, and say that between here, right-click edit form, select this edge here. Oh, symmetry is over the wrong edge. We want over this one too. There we go. I think that was the one I was looking for. Oh, I don't want to do a point. I'm just going to do a line. Edit form, double click on the line. There we go. This is what I'm looking for. So now I actually didn't want it, the other side to be, well, whatever. I'm going to make the worst looking wing ever. Oh, that's great. All right, I was just gonna leave it at that. That's my wing there. So now I could thicken this in here, but what I could actually also do if I get out of this again is that now you will see when I get out of this, this becomes a surface body right here. Now I can, but this is just a blanket right now. So you could go in here, Blake, and you could go in and say, I want to close this area off here, do a patch and close this off here. And now you will see I have free body, or free blankets, free surface bodies. If I go in here and I make these, select these free bodies, now they will become hollow, or will become full in here. But one of the questions there was in this email from Blake was about making everything, you know, his plane keeps on being hollow. So another tool you have available in here is, where is that now? In here is boundary fill. So you might want to try in that one. And what boundary fill does is that you will select some ends. You will close off the ends of this, and then it can close everything up. So if we went in here right now and we create a offset face here, let's drag it over here, this here. I think I can do it like this. Boundary fill. So our selection tool is this and this plane, and select that front plane there. And now I can actually select what I want to make solid in there. What I think if I select these two in here, hit OK. Now it actually made everything inside of here solid. Let's just hide that for a second. So now you get that solid body inside of that. So that will hollow up that inside shell that you're having right now. Let me just call the picture up again. So if we're looking at this right here, Blake, right now you have all these bodies, but I'm sure that if I zoomed in, inside of this is actually hollow. So if you're using that last one, the boundary fill, that's found underneath there, you should be able to fill up that space. But I went all the way to show you the different ways that we can make solids. We can make solids by just using the thicken command inside of the sculpt environment. You could go out like we did with the wing, where I actually added a couple of patch surfaces onto the surface and then stitch that together. Or lastly, you can actually, I don't know if lastly is a word, you can use the boundary fill and create a inside solid of that too. And then you could, of course, now you could go in and you should be able to combine everything into one body in the end, like this, and just say combine, combine, combine. And now we only have one body left. So when you print it out now, it's been working. I hope that was useful to you, Blake. Sorry about Fusion crashing on me. We're almost done here, I think. An hour and 25 minutes. That's got to be pretty good for a Sunday. Plus, it's getting warm in my office. Can you see that I'm starting sweating? I don't have the air conditioning running. I've got the 3D printer running. Okay, so this is from Eldon. Hey, Eldon, hope you're doing well. I would like to have a detailed discussion of the history line, talking about all the many symbols, colors, wiggle lines, broken lines, plus symbols, yada, 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 in there. So, Eldon, I hope you watched the beginning, and now I lost the files, what's the beginning if you just came in, where I showed how you can group things up inside of the history line. The other thing I wanted to show in here about the history line is that if we open up a sketch, and we draw something up here, let's just extrude that out like this, like that there. If we now go over and let's open up another sketch and let's draw a rectangle like this. Let's hit Q and make a cut like that, and let's put a fillet on it like this here. Now, one thing you might have noticed down in this timeline, so I showed before how you can group things together in here, how it shows association between the parts with the squiggly lines. So watch that video. But the other thing to keep an eye on down here is if I go down to the sketch that created this cutout, and I right click on it and I hit delete, you see how right now it gives you a warning and it turns yellow. Anytime you see stuff like this happening in your history line down here, you should go back and investigate and try to fix it. If you don't fix it, if you just are rushing and you're like, I'll look at that later, that's when you start having issues later on. Now, of course, right now, this is looking for that sketch. And if I right-click on it, hit Review Warning, that's what it's trying to tell you down here. I'm missing that sketch. Now, you could actually, if I right-click and edit it, you will actually see that it's looking for a profile right now. Now, if I roll back my tree to before that option, and I drew a sketch in the opposite corner, like this, finish that sketch. I could actually going in here and right click on our thing here and hit edit, and I could say, well, instead of using the missing profile, use this profile down here instead. Right now it should be happy, but when I do that, it will make the cut. See, that extrusion is happy. But you now see how I have red on my fillet. And the reason for that, if I go backwards, and maybe, hopefully this is useful to somebody, just undoing, Control Z. The reason that at this point there's no issues is the fillet is using these faces to know where that is, okay? So if I go in here and I say I'm going to create a new, let me just go back. If I roll before that first sketch, create another sketch over here and draw another center rectangle from here to here. And I now tell our original extrusion, see that extrusion right there? Stop using this sketch, but using this sketch instead. Edit the sketch. So right now it has this profile selected, but if I select this one, it will still be happy, but the fillet is not, because the faces that it was using to do the fillet, well, they're now gone. Whenever this is happening, you have a major issue. If we're going and edit that, you will see that it just have nothing to select. Now, I could go over here and select these two as my selection over here and use those instead. See, edit feature, select the edge right there. Shouldn't I be able to do that? Maybe not. There you go. Oh, I don't know why. Like that, and then you could do it like that. So you can just change where it goes, but that's how that is working. So I hope that, Eldon, if you look at the first one and you look at this one, that would help you a little bit. There was also a live stream I did do on this subject fairly early on. I think it was called Break Something. Not Break Rule Number 1. Not that one. Live stream number 13. This is good luck right there, right? Live 13, you will get into that too, where I'm kind of showing how to break that. So check that out. Okay, let's do one more. Then I think we'll finish up here. I'm running out of coffee and water. All right, so this one here is from Glenn. And talk about spacecraft, rockets, conical structures. Oh, so like if you're thinking like you have a spaceship, how do you add hedges and access panels and windows and things like that to a space shuttle? Well, we kind of already have a space shuttle, don't we? The closest you will find on my space shuttle in here. So how would you create a window in here or something like that? Well, it does becomes a little complicated, but if you watch that, I went through this, Glenn, you kind of saw how I made the wings and things like that. If you were going to do a window here, you could, per se, now where this is a solid, you could go in here and start a sketch on one of these windows, and you could draw something on a plane like this here, and we could add some fillets to it. Let's see, fillets. So let's make it 0.5. Let's make it 1, and do the same thing up here. So now we have a bunch of fillets in here. Finish that sketch, and then you could go in here and do a Q, and you could select that profile, symmetrical, and then you could get, you know, a cut through that. Of course, you probably wouldn't have. I mean, this looks a little toy-like, but you could also, as you're in here, just so you know, you could start adding some taper angle on this. So we could start playing with the taper of it and start making something that looks more spacey like that. But that's really how I would start creating windows and stuff, would be to create that. You could, per se, go in and create, maybe use something like a plane on an angle, and if we selected a line in here, you could create a plane that is skewed. So now there's a plane sitting in here. Now you can sketch on that plane that is sitting in an angle. So make sure we get the right plane here. So if I just draw a rectangle for a little window, and you would of course fully define it. Now Q, now that cut will come out in an angle because I had that plane on an angle. So that will come out like that. So I don't know how helpful this is. I think that's the best I got. All right, last one, and then we'll stop. An hour and 35 minutes. That's about all I got in me here on a Sunday. So the last one here is from Jan. Hey Jan, I live in Germany and looking to model something up that is too big, and you maybe want to put it back together again, like cut it and then put it back together with dovetails. So I did do a live stream on that topic in here. I think it was a live stream. Wasn't it a live stream? It might not have been a live stream. It might have been a season 2. in here. Let's go to playlist. Season 2. Put on the list here. I can't remember. No, I think it is actually a live stream. Is that like one of the last live streams I did? On the regular one. That one will show you something pretty neat. That will show you... Let's click on it here. Come on, YouTube. Oh, I clicked that on again. One of the last ones I did. Was that a dovetail one? Wood carving with... Which one was that? Somebody can probably remember that right now. There's one of them where I did a dovetail in it. Wood carving with sculpting, so I did that one. So then it's not... Then I was right before. Anybody watch the live streams when I was in my old office? Glad this is the last one now where I'm struggling, I guess. Let's see. What did I do with season 2? So what did I call those? Drafts and angle. Turning. Oh, here we go. If the part is too big for 3D print. Not for necessarily for 3D printing for you, Jan, but if you select this one for 2D print here, I actually in here, I model up different ways that you could combine things to put them back together again. And the last one I did was like a dovetail kind of thing. So you could model up too big and then you could fit it in together. But the other thing I wanted to show, and I wish that I hadn't had to go all the way back where I didn't have much cam. But another thing you can do in here is, so we already had some toolpath on this part here. So this is more for the cam people. If I go back to the design and I draw a new sketch, you can actually use sketch as the only area to machine within. So if I draw this weird sketch right here and we go back into cam and we go into, like, let's take the 2D contour here. Let's go ahead and edit that. You actually in here can do a instead of selecting the full chain, I gotta remember. Oh, actually, this is maybe just for 3x. Is this only for 3x toolpath? No, I can't remember. I knew this was gonna happen. Oh, we got the pocket selection. What's that gonna do? So now it actually only stay within, with the stock contour, it only stay within that area. And I believe that if I throw a 3-axis toolpath on it, that one has another option. When you go into selection, in here you could hit selection and you could select the area to machine within. So that's the two options you're gonna get there. Yeah, that's it. It's too hot. I'm done. Hope this was useful for somebody. The CPU is running hot on my computer. It's hot in here. It's Sunday. This was episode 3. I live streamed those both to YouTube and to Facebook. On YouTube is the wrong title. I gotta correct that. I'll go and correct that. So it's been processed. Just me trying to add a little bit more value, getting through some of my emails. I hope it's useful for somebody. And until the next time, hope you have an awesome, awesome day. Take care, folks.